lot of talks yesterday of interesting, very interesting talks, and I hope more. Check. Everybody hear me? All right. Check. So there are a lot of interesting talks, and I hope my presentation will be interesting too. So my talk called SCADA Deep Insight Protocols and Security Mechanisms. Before we start, a few words about me. I'm a penetration tester in a Russian security company Positive Technologies, and I'm also a team member of security researchers in SCADA software, SCADA Strangelove team. I made some few topics on conferences. So, as I said, I'm from Russia. Okay. A few words what I am going to talk about. I will give you a brief overview of what is SCADA, some terminology, so I'll describe a little bit the current situation in security of SCADA, and we'll give you some overview of most popular protocols, because I forget that be a penetration testing, my main specialization in security research, it's industrial protocols. Well, and I will go a little bit later, go deeper. I describe some interesting protocols. Part of them are open, and another one, the proprietary protocols. So, be careful. So, I won't talk only about protocols, so I also show you interesting features, security features of SCADA software, and show some demos. And the final of my presentation, I will give and show my approach how to analyze proprietary protocols. So let's start. So I don't waste time to discuss some terminology words. So it's the main that we should know and to understand that, for example, PLC, it's my best friend in security research. You can see on the image, it's typical programmable logical controller from Siemens company. Also, a very interesting part of research, it's HMI, human machine interface, and so on. Well, what is right now the situation in the SCADA vendors? There are a lot of vendors that gives us decision to create automation systems. There are a lot of big vendors like Siemens, General Electric, Schneider Electric, and so on. And most of them give us their own decisions, their own protocols and technologies. It's the main problem in security, because each vendor creates their own protocol, technology, and so on. Because a lot of vendors, as I said, it's a main problem that they have own technology and protocols. Well, what is also problem in security of SCADA? It's most of them is right now out of date. It's the main approach that if it works, don't touch it. And another one, it's patch management cycle, because we can break, we can reboot the whole system or the part of the system when we apply a new firmware, for example. So I think it's these three kinds describe that mostly it's industrial world. It looks like a really wild. So what about current situation in industrial security? I think most of specialists thinking that it's absolutely unbreakable. No, because Typical network devices works with default or crappy settings. Most of them unpatched, not only about engineering stations. All of them old as dirt and full of junk software. Sometimes during penetration testing of companies, I find out that they set up their wireless access point with very old encryption technology like VIP, if the best happen, but sometimes it's completely open. If you have a big antenna, for example, you can connect. So another one that it's low physical security. And the final step it's about industrial protocols. So I decided to concentrate on protocols because another steps it's maybe sometimes it's obvious. And so how protocols live in the network? Most of them, and it's a typical situation, they full expanse and it's not blocked by network devices, switches, firewalls. Protocols lives in all LAN segments and accessed between LAN segments. Industrial protocols easy to detect on the network traffic, and sometimes it's easy intercept, analyze, reproduce, and replay. But not at all. Well, it's most popular list of protocols. Most of them well described. For example, Modbus, Profibus, Profinet, DNP3, and so on. But some of them not described very well from point of security research. So it's just a remind what is SOC network model. Well, let's start and talk a little bit about a very popular Modbus protocol. It's firstly published by Modicon company, now it's acquired by Schneider Electric. It was about 35 years ago, and mainly it's widely used for connection industrial network, electronic devices. In previous century, as a physical layer, it was RS-232 or RS-485. Then next they switched to network TCP stack, and typical standard port for Modbus devices it's 502. Well, what kind of functions Modbus provides us? It's simply data access, read-write, diagnostic. It's very interesting function that you can acquire information about device, their settings, and so on. Also, Modbus protocol give us to create user-defined functions. Here is a simple example of Modbus network traffic. What kind of tools for Modbus we have? It's Wireshark dissector. Also, my colleague wrote a tool called PLC scan. It works with Modbus and Siemens S7 protocol, old version of S7 protocol. Also, we have for Nmap script to discover Modbus devices, and to play with Modbus we have some simulators. Well, what about security in Modbus? It doesn't have no authentication, encryption, and as a result, it's we can say it's no security in protocol. Well, it's some characteristics of headers and fields of Modbus protocol. Well, another one, it's DNP3. It's also very widespread protocol, distributed network protocol. Firstly, it was published. First version was in 1919, and but only 4 years ago it was standardized by international company. Mainly used for water and electric industry, and to discover devices, it's just simply scan for port number 20,000. And what kind of tools? It's also Wireshark dissector, and we have free implementation of the DNP3 network protocol. some security features, but it's not very implemented, and it's not really implemented in real situations. It's the NP3 secure authentication. We have it's part of standard, and it shows you how to authenticate users and devices and how to protect data. But in real situation, I've never seen that it's already implemented in industry companies. Here's a few characteristics of the NP3 frame. Well, so the next one of interesting for me, especially for me, it's Profinet family network protocols. We have a few protocols in Profinet, CBA, IO, and so on. And I will talk about DCP. It is discovery and simple configuration protocol. Profinet works on second layer of network stack. It has the net header 8892, and the mainly used to exchange in real time and real cycles between devices some data. Also, it has some interesting characteristics that multicast discovery devices and stations. So because it works on second layer, it's no security as a result. Well, as I said, we will talk about Profinet DCP. It's simply discovered devices, obtain information about devices, and it has some features to set up some settings of devices. So it's, for example, you can see a simple example of how to identify multicast request on the network and to get information about devices. Here is hex values of the packet data. Well, it's example for SCAPI Python. Well, the main interesting field for me during the Profinet research was that playing with option and suboption. Here's it's the last 2 bytes of the header. Well, for example, we can get network information with option in hex 1 and suboption 2. For example, we can send LED flashing, it's to device with option 5 and suboption 3. Well, as a result, we can scan whole network, whole physically accessed network, because we work on second layer. We can scan Profinet supported devices, not only PLC, but also engineering stations, HMI, RTU, and so on. With Profinet, we can change the name of the station, change its more important network settings, for example, and send LED flashing. It means, from the point of view of, for example, of engineers, that something wrong with PLC or HMI. Well, here is an example how it works. I wrote Python script that one of them works on raw sockets and another one for SCAPI. Well, finally I wrote a simple fuzzer to send requests playing with suboption and option, and as a result I found out some interesting CVE that attacker could cause the device to go to an defective mode, simply sending a specially crafted Profinet packet. So what is a specially crafted Profinet packet? It's just simple, you send network settings with all zeros, IP, net mask, and gateway. Yeah, so I will show you some example how it works. Just a second. Right. So firstly, we scan the network. Option is network interface. So we receive an answer. You can see that PLC has IP address like this, and this MAC address of device. So it's easy. Then we send some options to set up network information. We should provide source MAC address and destination MAC address and network settings. Right now, I don't remember my interface MAC address. Okay. In combination with another vulnerability of PLC, Profinet vulnerability, and another one that I will show a little bit later, it's more powerful in the hands of attacker. So before we start network information, we just ping in our network device. It will be still pinged, but here's to ensure that web interface, for example, of PLC working well. Before we start, so okay. Well, we sent packet data. As you can see, pinging not replied right now, and again starting to reply. And right now, PLC in defective mode. On the top of the PLC, you can find that LED flashing. Yeah. Okay. It's okay. Well, stop. It's another one. Just a second. Well, a few words about another very popular protocol, GOOS. GOOS is Generic Object-Oriented Substation Events abbreviation. There is a list of few characteristics, but most of interesting for me, it's also as Profinet, it works on a second layer. It uses VLAN technology, and it has two characteristics of data. First of them, it has a message priority level and a retransmission mechanism. It means that when we, for example, we get a new data, we send with a flag that is a new data. And following this, you can imagine some attack scenarios. For example, it's easy to receive multicast broadcast packets. Also, it's easy to analyze, modify, and replay. Following that it has, for example, just a second, message priority. For example, we can make DDoS of devices that support the GOOS protocol. And by manipulating the state number in packet, we can control hold the data on the network, and also LAN hopping. Well, it's some tools. Usually, it's also Wireshark dissector, and it's easy to create. For example, on SCADA framework. Another one. Popular tool protocol is manufacturer message specification. It's abbreviation of one IAC protocol. Well, here's functions. For example, we can read, write text, some registers or variables on the controller. On devices, we can send a packet that will start, stop, or rewrite firmware on PLC and read, write some kind of files or directories of context of device and protocol of MMS. Well, there is no security feature except a simple methods whitelist. It means that some devices has a list of methods that all of each other supports. Well, also it's in theory we have an TLC implementation, but in practice I never seen that it's already supported by vendors, and in products I haven't seen. Also, it has Wireshark dissector, and I wrote Python and Nmap scripts which can find out and identify devices with MMS protocol. Here is an example of networked traffic. Well, it's an example of how it works. Nmap script. Another one is IC 101, 104. It's a little bit different between because 104 works on network level TCP stack. There is a huge list of functions. It also depends on vendors which implemented this kind of protocol. What about security? It's a simple IP address whitelist. So, as you know, it's easy to spoof IP addresses. Well, what kind of tools? Also, we have simulators, Wireshark dissector, and I wrote Python and Nmap script to identify devices which support this kind of protocol. Well, here is a simple example of network traffic. Well, it's how it works in Nmap script to identify devices with IC 104 protocol. Well, previous protocols was opened, and next will be a proprietary protocol by Honeywell company. It's fault-tolerant Ethernet. It's not only a protocol, it's technology which provides robust and low cost for industrial networks. The main idea of FTE is that each node connected twice to the network, and each connected device supporting in real time actual routing table how to send data between devices. Well, FTE uses UDP protocol as a transport, and as I said, it's proprietary. Well, during penetration testing of an industrial company, when I saw FTE, I imagined some kind of attack vectors, successful attack. For example, it's easy to flood UDP ports and send multicast packets with fake routing table. And it means that you can control, modify in real time all the data that change nodes between each other on the network. So here's a simple example of multicast packet of FTE node. Well, some characteristics of data. For example, in hex 23, it's node index. It's some kind of number or address between network devices with FTE network. Well, each device provides a node name. Honeywell C300, and it has some packets counters, and the bottom of the data we have full information about firmware. So we can see it's implemented and compiled 6 years ago. Well, the big part about Siemens of my talk, it's not only about S7 protocol, but also about Siemens SCADA software called TIA Portal. Well, firstly, I think it's main interest of security researchers, and another one, real people, that how works users and passwords and user rights protection and permissions. For example, from the site of TIA Portal, you can configure and set up password that read and create on controller read-write protection for main and critical functions. For example, it protects CPU start-stop, data change, for example, it's project upload and so on. Well, Here's T-Portal has a project file called P-Data, for example, and I don't know for what, but T-Portal store has previously set up passwords. It has passwords history on the file, so all passwords encrypted with SH1 algorithm, but some interesting field of the PA data, red box value, you can see that it helps us to crack the passwords in real. Sometimes it's really easy and in real time. Red box value shows us which the length of the password. For example, 7. It means that password was length of 3. For example, 1, 2, 3. Okay. When we send notification to Siemens about this, it's not really a security feature, but they improved, they changed the user password and switched to MD5. Some strange. Okay, I wrote simple Python scripts that can extract password hashes, and you can brute force it. Okay, what about user rights? In the last T-Portal version, you can set up some user rights, and as you can see on the left image, you can see that some of them not accessible through user interface. But if you change on data a few bytes, you will be a super administrator, I think. You can see on the left of the image. Sorry, right. Just change 2 bytes. I will show you here. Here it is. This one. Okay. So, more interesting part of how works, how authenticated the SCADA software. It's not only T-Portal, also HMI and another one, and PLC. So it's widespread in the typical authentication scheme, challenge response. Well, it uses HMAC and SH1 algorithms. So I wrote a Python script especially for controllers to 1200 and 1500. They extract all challenge responses and also export into John the Ripper format, and you can simple brute force it. Okay, it's offline brute forcing. Here's an example how it works. Well, to be honest, for previous version, for 1200, it can give you information that challenge response authentication was success, that the password was correct. But for another version of the controller, we don't know. Maybe you know. Well, I wrote also Hydra model to brute force PLC passwords online. It works on old version of Siemens S7 protocol, and you can find out a lot of S7 300, 200 or 400. It also should work on this kind of PLC. You can find a lot of connected devices to internet through Shodan and simple brute force. Okay, here is a part of Hydra module brute force in PLC, and everybody see normal that code. So it is 2 interesting things, crappy things about security. Who knows? So the second line of the code shows us that password length should be only 8, not more 8. Okay.
What's the case of
Sorry?
Mixed case or just a
Mixed case. Well, but here is some preparation of password. If password len user password more than 8, it's skipped. It takes only first 8 characters, and if password less than 8, it concatenated with appropriate number of spaces. Okay, so is this kind of encryption. So it's, as you can see, it is simple XORing of characters. Okay, good security. Well, here's how to obtain full access to, just a second, PLC. Okay. So firstly, I'll show you that we have this kind of IP address. Well, the first step, let's imagine that attacker connected to internal network, and we send Profinet identifier request. We find out that our PLC and another one network. Okay, and we don't have access, for example. Okay, so we send Profinet packets to change network settings, and as a result, we will have access to PLC. It's only to ensure that we do not really connect it. Okay, we got a response that network, so just ensure that IP address of PLC changed. Okay. Again. Well, it's a typical network interface of PLC. So let's imagine that administrator goes to web interface, input real login and password, so on, and for example PLC started. Okay, how to get access? Usually you can simple spoofing on the network, but we will do by another way. So we can see that we get some numbers. It's 2 numbers, and send, try to brute force cookie. Sometimes it can be success in a few seconds, but sometimes it can take some minutes. Okay, so let's ensure that we don't know your real username or password from the attacker's point of view. Well, we find out real valid cookie. Just kill Python script. Okay, let's copy paste. Reload, and whoops, we are administrator, and we can stop PLC. Okay, so now I will explain how it works. So it's a story about some vulnerability which our team found out previous year. Well, we tested on on two versions of PLC, Siemens 7. Here's a description from NDIST, as I remember, site. It means that the main problem of PLC is low entropy of PRNG. Well, we tested on 1200 with this kind of firmware. Well, firstly, let's take a look of 4 examples of real authentication cookie. So it's, as you can see, it's base 64 encoded. It's simple, and if you take a look of the hex values of cookies, you can find out some patterns. Who can see? Oh, well, it's obviously that some kind of right part or it's repeated on the cookie, and the first part some kind of the length. For example, it's MD5. Okay. Well, I divided the cookie in 2 parts, and the next I divided to here it is 6 parts. Well, it's trying to figure out what is it, what its values. Playing with authentication process, I find out that, well, its first part was MD5 of something which right now we don't know. The next value was 4 bytes of some constant value. Next 2 bytes was number of user logout. The next 2 bytes was a counter of issued cookies to this kind of user, and the next 4 bytes was a value that doesn't matter for us. We can only fill this with zeros on another one. Well, next 4 bytes was a user IP address. It's easy to spoof, and another big part was a value that also doesn't matter for us. So firstly, we can figure out what is MD5. So during some kind of reverse engineering of firmware of PLC, we figure out that MD5 of next 26 bytes of cookie value, plus 16 bytes of some secret, and plus 2 null bytes. Well, what is this secret? Usually secret, we decided that secret generates after PLC start by some kind of PRNG. We figure out on reverse engineering of firmware. PRNG, it's a little bit harder than a standard C generator, and for PRNG we use this 2 bytes as a seed. And you can see part of Python code, how it works. So a lot of value right now to create a brute forcer. So because PLC is so tender sometimes. Well, what is a seed? Seed very often depends on time value, and by practical way, playing with PLC authentication, I figure out that seed, it's PLC start time plus some constant value. As I said, it's constant value by practical way, because PLC generates the secret after about 3 or 4 seconds when PLC start, and it uses a current time on the PLC. So how to obtain PLC start time? So it's obvious that it's current time minus uptime. Well, current time you can obtain without any problems through web interface, as you can see on the image. And uptime you can get through SNMP request. if SNMP enabled on PLC. By default, I think by default it's enabled, and Siemens hard-coded SNMP public and private strings, community strings, and it's not changeable. Interesting. Here is an example how we send with nmap. Well, here is a part of Python code how to get the seed range. Constant value 100, it's calculation labs, for example. So right now, to generate cookie, we should brute force logout number. It's 2 bytes. Number of issued cookies 2 bytes, and seed value 2 bytes, but maximum values it's 100. So still too many value to brute force because we can go to put PLC to the defective mode. It's not our main goal. Well, next I decided to play with logout, login, how it works, and I figure out. But if user not log it out properly, then after 7 logins, it's not possible to log in again. So right now we should restart PLC or wait 30 minutes. It's a cookie expire time. So right now we can minimize logout and issued cookie values, counters to 7. And so right now we can generate cookie, should brute force not so many values, only logout numbers, it's 7. Number of issued cookies also maximum 7, and seed value maximum 100. Well, I wrote 2 Python scripts. First of them get seed range that send raw SNMP request only to obtain uptime and to grab information through web interface and calculate in seed range. And as you can see on demo, we can generate real valid cookie and authenticate it. Well, some strange I can think in authentication scheme. It doesn't require any username or password. Well, it's 2 dependencies of exploitation, successful exploitation. It should be more than one or more success logins to PLC after last restart, because when first login success on PLC, it's in internal memory creates some kind of table with issued cookies. Well, you can see vulnerability timeline. It took a lot of months to release patch. About 1 year, a little bit. Okay. Also, very popular nowadays, Heartbleed. Also, a lot of vendors' devices affected to this kind of vulnerability. Because of patch management cycle, I think it will be a long story. Because of patch management devices with life cycle about sometimes it's 10 or 15 years. So on CERT you can find out a lot of vendors with OpenSSL vulnerabilities. Also Siemens vulnerable to Heartbleed. So I will show you. This is not hard. Well, we started to grab memory from device, and let's imagine that real administrator connected to WinCC. It's kind of a web interface of HMI. Well, it's as you can see, it's basic authorization. Strange is asked again. Well, we already grabbed authorization from the log file. So I don't show you real password because it's our testing laboratory. So we stopped to grab memory from WinCC web server. Well, it's base 64 encoded values. Well, let's close the window and send grabbed value to base 64 decode. Administrator and some kind of password. You can guess that it's simple. A little bit more characters. Okay, we copy paste password. It's not a trick. Okay, it worked. Stop. Well, we don't have enough time, I think. Let's continue. A few words about S7 proprietary protocol. It's my headache because I work with S7 protocol, last version of S7, and a lot of my work time. Well, it's you can see a standard scheme of how protocol S7 works on ISO-C model. It uses standard TCP port 102. It works by Siemens terms on ISO and TCP based communication protocol. Well, in context of research, it doesn't matter for us. Just it's a little bit different from TCP. Well, what kind of materials of research were interesting was made by Dylan Beresford, exploiting Siemens semantics and PLC. Firstly, he showed his presentation made, I think it's on Black Hat. For previous versions, we have Warshak dissector. It's easy. We have some kind of free communication library, libnode. It's two for previous versions of 7 protocol, and also Snap7 and PLC scan. As I said, it's based on ISO on TCP protocol. It means that it's block-oriented protocol. Each block called PDU, protocol data unit, and functions and comments oriented protocol. It means that each frame contains request or response for some function. Well, list of S7 comments is huge, but most of interesting it's with S7 we can start or stop CPU, send firmware update, read-write some kind of data, blocks, tags. We can grab system information, and more interesting for me, it's authentication scheme. Well, as I said, 7 has previous versions called S5. And next version we called 7 communication, and the final in our research we called another 7. Well, it is simple another 7 here of the frame. Well, for all versions, as I said, we have Warshak dissectors, some kind of tools, libraries, but because we know all about that version of protocol, but we know next to nothing about another 7, so decided to figure out how it works and create some useful and helpful scripts to parse that helps me to understand the packet fields. Well, firstly, when you can see some kind of hex mess of network traffic, well, the main approach I I got from Rob Savoy. He's very interesting. I highly recommend you if you are interested in proprietary protocols. Very interesting talk was in FOSDEM 5 years ago, reverse engineering of proprietary protocols. And the main idea that was if you stare at the hex dumps long enough, you can start to see some patterns. Well, it's simple example. Oh, not very good quality. Well, it's how it works, how I parse with Python scripts communication traffic of a 7 protocol. Well, first script, it's show byte sequences. It's show repeated sequences of network traffic. Well, the next one, it shows some kind of payloads and colorize some fields if you're trying to figure out what these fields means. And as a result, I wrote, I can call it the part of Python dissector for a 7 protocol. It shows you the packet structure. Well, at the end of my presentation, I want to say that just use your knowledge about protocols, because from the security researchers' point of view, it's universal and complex approach, because you can patch software, but protocols lives long enough, and you can, with your knowledge about protocols, and detect devices and their protocols. You can monitor state, commands, and exchanging data, and using some scripts, some technologies, you can inject, modify, and reply packets in real time, because most of them are insecure by design. So I'll give you some real example. Well, during the penetration testing of some energetic company, I got traffic dump and trying to figure out what is it, how it works. Well, it was traffic between PLC, which sends some data, some kind of hex mess to RTU, which then sent special commands to energetic turbine. Well, as a result, I figure out that it's a simple UDP packet that sets speed of turbine to 57. Well, minimum value was 0 and maximum 100. Okay, well, what do you think? What will happen if you send another packet, another value to PLC? It was really to replay. Okay, you're right. Well, at the end of presentation, all scripts, all tools that I made and wrote, all of them open source and accessible on GitHub. Well, I want to say thanks and greets to my colleagues and full SCADA Strangelove team. So, thank you. If you have questions, just feel free to ask me. Thank you.
Are there any protocols that could be used for PLCs that are not cracked? That have authentication, encryption and...
Sorry, what do you mean of crack?
Are there any good protocols, any implementations of protocols that have authentication and
I think some of them are really good. For example, S7. It's really hard to understand what's going on, but most of them that open sourced, or for example FTE technology, or this the end of protocol that I showed you, they are proprietary, but they don't have any authentication, what kind of data send it, authorization of sender, and so on. For example, most of popular protocols like Modicon, DNP3, they was designed a lot of years ago, and engineers don't care about security. They don't care only of life cycle, I think, and how data, the data should be exchanged between devices in real time, real cycle, but some security features increase the gap of time between data changes. Yep.
I have a non-technical question. I left the industry 10 years ago, in industrial automation, but many of the security problems I've seen were more down to bad engineering of PLCs or their environment. But what I also remember is that a lot of vendors were, if not arrogant, then sometimes outright hostile towards engineers actually explaining them that some things were not as safe as they were supposed to be, at least in the environments where they were deployed. Have you seen any change in that attitude from the big vendors?
Any change in
attitude towards security-related issues?
Well,
do they address them any better in the last decade?
Some big vendors try to reply quickly to security features, security problems, but for example, especially for Siemens, they have a big patch management time, but not only vendors, but some companies, industrial companies, last years from, I think, you know, from the Stuxnet time, 4 years ago, they started to care about security and started to ask penetration testers, some companies, to discover, to check their internal network. But nowadays it's a lot of devices and a lot of network and companies that fully connected to internet and accessible.
I know. So it's no longer that the first reply is from the lawyer telling you to keep your mouth shut.
So, what do you mean?
Well, that was a question. That's apparently not the first response anymore. They actually do take their report seriously, I get. Because I really have been out of that industry for 10 years, so I really wouldn't know anymore.
Well, I don't know how to say.
No, because you are doing pen testing, so I assume that if you do find a vulnerability, you would have interaction with some of these companies.
Sure, we interact with this company, firstly.
And you don't get an immediate reply from the lawyers? Okay, fair enough.
No.
That was the question.
Yep.
And the answer.
Okay, if no questions, just feel free to ask me. Thank you.